Hello everyone, welcome back to Physics Forum. So today I'm going to deliver lecture on calculation of center of mass of discrete system of particles. But before we actually start, first we need to understand what exactly is center of mass. So let's understand it through an example. So suppose we have a rod which is placed on a horizontal floor, and we apply a force at one end of the rod like this. So the motion of this rod would be translatory as well as rotatory, and the sense of rotation would be clockwise, right? Now again, if we apply the same force over here at the other end of the rod, right? So again rod will translate as well as rotate, but this time rotation will be in anti-clockwise direction. And if we apply force exactly midway of the rod, then it will only translate. There would be no rotation motion. So we might say that at this particular point, this entire rod will behave as a particle mass. As in case of particle, if you apply force, there is only translatory motion. So we can assume that this entire mass of the rod is concentrated over here, right? And this point is known as center of mass. So we can define center of mass as that point which may be lying inside as well as outside of the body, where entire mass can be assumed to be concentrated, right? So like in this example, the center of mass is lying within the body, but there are examples where center of mass can be lying even outside the body, right? Suppose we have a circular ring, right? So mass is distributed over this profile, and center of mass is lying outside it, right? Somewhere here. If we have L shaped of an object, again center of mass is not lying inside the body, but somewhere here outside the body. So from all these examples, this is clear that center of mass can be assumed, uh, center of mass is that point where entire mass can be assumed to be concentrated, and at center of mass, presence of a mass is not a must, right? Like here there is no mass present over here, but still it's a center of mass of this body, right? So center of mass can be lying inside the body, or it can lie outside the body also, right? Now we have two system of particles. First is your discrete system of particles, in which all the particles are separated from each other, right? So we have two system of particles. First is discrete system, and second is continuous system. So in discrete system, all the particles are separated from each other. So in space, some particle will be lying over here, some particle will be lying over here, right? So all these are not associated with each other. While in case of continuous system of particles, all the particles will be associated with each other. Like in case of rod, in rod, all the particles are associated with each other, right? This is also made of infinite number of particles, but all particles are associated with each other. Or you might take an example of disk or a sphere, right? So in all these examples, all the particles are associated with each other. While in discrete system, all the particles will be separated from each other. There would be no connectivity between any of the two particles, right? So how to calculate center of mass of discrete system? Let's see. So we first calculate it for two particle system, and then we are going to generalize it for n number of particles, right? So suppose we have two particles, m1 and m2, right? And over this we apply a force F1 and because of that an acceleration is taking place on particle 1, and we apply a force of F2 on M2. Because of that acceleration of A2 is taking place, right? We can take position vector somewhere here, and we can define position vector of M1 to be R1 and position vector of M2 to be R2, right? So we can expect its center of mass of this two particle system to be somewhere here in the midway, where entire mass M1 plus M2 can be assumed to be concentrated, and on this and position vector of this of center of mass, that is RCM, and here this entire mass M1 and plus M2 is concentrated, right? So net force acting on this center of mass, that would be F1 plus F2, right? So we can write down that F external is equal to F1 plus F2, and we know that F external we might write M1 plus M2 into acceleration of center of mass is equal to M1A1. Because of this force, individual acceleration of the bodies are M1 and M2, and this is M2A2, right? Now in differential form we can write down ACM to be d square RCM by dt square, and this can be written as d square R1 by dt square and M2 d square R2 by dt square, right? Now if we can associate this M1 plus M2 with RCM, how do we have written this expression? We know that velocity is given by differential rate of change of position vector, right? So again if we write down acceleration, so this comes to be dv by dt, and this can be written as dr by dt. V can be written as dr by dt, so this comes to be d square r by dt square, right? So again we can associate it like this: d square by dt square m1 plus m2 into RCM, this equal to d square m1 r1 by dt square and d square m2 r2 by dt square, right? Now if we compare both sides, we can definitely write that m1, comparing both sides, m1 plus m2 RCM is equal to m1 r1 plus m2 r2. So RCM comes to be m1 r1 plus m2 r2 by m1 plus m2. So this is final expression for position vector of center of mass, right? Now how to use this expression, right? Suppose we have a two particle system, right? M and 2m, right? So the first thing we are supposed to do, that we have to define our coordinate system, right? So let's say that this is placed at origin and these two particles are placed along x-axis, and the separation between these two is L. So coordinate of this one would be 0, 0, 0 for x coordinate and 0 for y coordinate. So as there is no y coordinate over here, so y coordinate will be 0, and this would be L, 0, right? So by definition of center of mass, RCM, and we call it, we number it 1 and 2. Now we can write down M1 R1 plus M2 R2 by M1 plus M2, right? So M and its coordinate would be null vector, as this is placed at origin, and this is 2m, and this can be written as Li cap, right? It has no y component, so Li cap by m plus 2m. So this comes to be 2l by 3, right? So this is center of mass of this two particle system. So center of mass would be lying somewhere here. So had two masses been equal, in that case center of mass would have been exactly midway between these two. But as this one is heavier than this one, so the center of mass will be slightly shifted towards 2l, because this is heavier, right? And this is what is happening. This is 2l by 3 is definitely greater than l by 2, so this will be closer to mass 2l, right? So for n particles, we can generalize this equation. For n particles, this can be written as RCm is equal to m1 r1 plus m2 r2 plus mn rn by m1 plus m2 plus mn, right? And also, if we wish to calculate xcm, ycm, zcm separately, so in that case, from this equation only we can deduce that m1 x1 plus m2 x2 plus mn xn by m1 plus m2, right? Similarly, ycm can be written as m1 y1 plus m2 y2 plus mn y1 by, and similarly z coordinate can also be written, right? So procedure is same. So either we can calculate separately xcm, ycm by putting the coordinates, individual coordinates of each particle. Like if you wish to calculate xcm, then only x coordinate should be taken, and if you wish to calculate ycm, then only y coordinate of individual particles should be taken, right? But in general, we can directly calculate with this formula, in which both the coordinates will be taken care of, right? So we can use this formula only, and with the help of this, we can definitely calculate center of mass of discrete system, right? So I hope you like my video. If you like my video, subscribe to my channel and hit the bell icon. And this would be really, really encouraging for me. Thank you for watching. Thank you so much.